This is Panasonic microwave that I just bought. It was already marked as having been returned. So when I turn it on, it seems like the magnetron's not working. So now I'm going to see if I can unplug it. And my pocket knife, once again, is able to unplug these tamper-proof screws. So that's pretty awesome. All right, I'm going to stop. I'm going to start a new recording when I have all the screws off. I'm able to use my Leatherman to unscrew the tamper-proof screws. So I decided to try these small screwdrivers that I got for electronics. And after I tried the smallest flathead, I was able to stick in there and then apply force to the side, and that was able to get it open. I don't know if I'll be able to. I can't really record a video of me doing it, but I was able to get the screws unlocked that way. Just undid. Let's see how many screws there were. 1, 2, 3, 4, 5, 6, 7 screws about, and I got them all here. So there was one here, one there, one there, one there, one there, one there, and one there, and then you just pull the thing off. And so there we go. So now I'm going to put this over here where the box is. And here is the microwave. So it's unplugged, important to note. Unplugged, very important. And this looks just like what I've been watching on YouTube for the past hour. So this is the magnetron. This is the inverter. And these are printed circuit boards, and I don't really know. I guess this is the interface, and I don't know what that does. But it looks like it's the magnetron that's not working. So in the YouTube video I saw, the guy was running the microwave with the top off. So I'm going to be a little bit bold, and I'm going to do the same thing. I'm going to try to run it with the top off. Okay, so plug it in. Okay, it's plugged in. And nothing on the screen. Okay, so I'm going to try the other plug. So take that plug out. Plug it in here. Nothing on the screen. That's not good. So before, when I plugged it in there, stuff was coming out on the screen. So unplug that. Plug it in there. Oh, here we go. So now something's coming on the screen. So I'm not sure if those plugs are bad or what. Okay, so now what I'm going to do is, what am I going to do? Now I'm going to try to run it. So I'm going to hit power level all the way down, run it for 4 minutes, start. Okay, so there's the fan. You can see the fan spinning. And so that's the light that shows inside the microwave. And that's the magnetron that should be producing the microwaves. And I think it's supposed to be making noise. And it's not making noise. And so what they do in the videos on YouTube is that they then use a multimeter to check the electrical connections to make sure that there's current flowing. So that would be the next step. And then they also look for burnouts. So like in one video, that thing was burned out, and so the guy replaced that thing, and then it started working again. So yeah, I don't see anything that looks very broken. So now let's see what happens, because sometimes it stops working. So now let's see the case in which it stops working. So I hit power level 10, and I'll do 4 minutes. start. Now let's see. It should stop working after about 30 seconds. And I don't know why. I mean, it just kind of turns off after a couple seconds. Oh, there we go. And I heard a clicking noise. So maybe that's like a fuse or something that's going off. I don't know. But there you go. There's the problem. So now the question is how to fix that. So I'm going to take a few minutes to poke around and see if I can find something interesting. Okay, so I spent some time poking around. So this is, the power cable, obviously. So this is where the power comes in. And I guess this is like some kind of power regulator thing. And it plugs in there, and it plugs in there. And I remember seeing from the other videos that this is the main fuse. So if the thing doesn't, if the power supply, if the microwave doesn't come on at all, you want to check this thing. So then I was following these cables, and I was following them along, and I came to this thing. And look at this. This is the light bulb that turns on, that makes the inside of the microwave light up. So that's kind of cool. Looks like an old-fashioned kind of light bulb. And so I'll put this back in here. Goes back in there like that. And then it kind of clips in. You like pull these things back. There we go. That's not all the way in. There we go. And the reason my attention was brought to that was because this thing looks a little discolored. So from the videos I watched, I learned that the discoloration sometimes means that there's a problem there. But the light seems to be working fine. So that's not, I don't think that's the problem. And the other thing I saw that was kind of cool was when you push the button, like how this thing disconnects all the power. So you push the button to open the door in the microwave, and it engages that thing, and I think that's like the fuse that disconnects the power. So that's kind of cool. So close the door, and then it opens. Open door, close the door. Open the door, close the door. So this whole part of the thing seems to be working. The light part seems to be working. I was able to open the inverter thing. So the way you open this, it was kind of tricky for me at first, is well, I don't even know how to close it all the way. Well, basically the way to open it is you push it forward, which is not obvious at first. So once you push it forward, then it comes on, this top part becomes unclipped, and then you can open it up. And I don't know the way that this guy in the YouTube video checked if the inverter, so this is the inverter, and I think the inverter is used to control the magnetron. So like you can dial down the power or dial it up and do fancy things with the power. And the way that the guy in the YouTube video checked if the inverter was the problem was he swapped out another inverter, and I don't have another inverter, so I can't do that. So yeah. The cool thing to look at, so this is the fan that spins, I guess to keep everything cool, and this is the motor that spins it. So that's neat. And then I don't know what the purpose of that coil is, but the thing that I noticed was that these are the two things that power the motor. And so if you trace this back, the orange one, and you follow it and follow and follow it, it goes back to here, to one of these things. And that is the switch that when you open the door, everything gets unplugged. So that's kind of cool. Just watched a 30-minute YouTube video on how to use a multimeter, and they showed me, the guy showed me, it was a really good video, and the guy showed me some cool tricks. So the first trick he showed me was just to test the voltage on a battery. Well, the first thing he said is that testing the voltage is a lot safer than testing current. And the reason is that just like if you were testing the water pressure on a big dam, if you make a really small hole in the wall of like a pipe or something, as long as the hole is really small, you can test the pressure without being in a lot of danger yourself, because you can always plug that hole so that there's not a lot of water spitting out at you. And so that's the same thing with electricity, where to test the voltage is like the pressure. So you can test the pressure, the voltage of the battery, and not be in that much danger, because you can limit the current, you can limit the water pressure. And so to test and that's why he suggested that to start, if you're going to mess around with measuring electricity, you should start with voltage. So the first thing he showed me how to measure was the voltage of a battery, and all you do, it's kind of hard to do this, but all you do is you just put the black end on the negative and the red one on the positive, and you get, well, it's kind of difficult to keep my, well, 1.57. If I was keeping it with my hands tight, it would stay at 1.579 without moving. Now the second thing he taught me is how to measure, so that's direct current. The second thing he taught me how to measure was alternating current, and that is on this setting here, and you can see that little wavy line above the V. Maybe you can't really see it that well. Let me see if I can get this closer. Oh, perfect. So you can see the wavy little line above the V. That means alternating current. Whereas with this one, wow, that's a really good camera. With that symbol, that means that that's direct current. That's direct current, that's alternating current. And he said it's very important not to get them confused. You want to have it to the right setting. And so that is something just to measure, like 1.5 volts is a common AA battery. So that's specifically, that's a setting if you're going to measure a 1.5 volt battery. And that's like a 9 volt battery, that's a 12 volt battery for like a car. The 9 volt battery is like the rectangular batteries. And so the second thing he taught me was how to measure alternating current. And alternating current is what you have in your house. And he also said it doesn't really matter which end you stick where. So he did it with his thing, and that made me bold enough to stick my metal probes into this thing, which normally I would have been very afraid to do. But you just stick it in there. You stick it in there, and look at this, 123. So, you might know that the voltage of the house is 120 volts, 120 volts. And he said that in South Africa, where he is, it's 240 volts. But that's really cool that now I know how to test whether or not an outlet is working. That is the cool thing. Like, I can now stick this probe in here and I can see if the outlet's working. So you can see how this one's a lot looser. What I noticed when I was testing these is that the bottom left one had like the tightest grip, and that the other ones weren't as tight. They didn't hold on to the probe as tightly. And that might explain why, so there we go, 123. That might explain why a device might have a harder time. You see how that kind of falls out? That might explain why a device might have a harder time, here, 120 volts. Might have a harder time getting a charge from one of these things. So now the other trick he showed me is how to use alligator clips to have your hands free while you're measuring voltage. So I think what I'm going to do is I'm going to start measuring the voltage on these different components to see if I can find out where the voltage is not going. So I'm going to get the alligator clips and then I'll make another video. First test I'm going to do is direct current. And the guy said in the video, always start with the highest setting first, and then you can always go down to the lower settings if you find that it's too high. And I'm going to measure the voltage for this light bulb that I was looking at earlier. So I've got one alligator clip tying the one clip there and the other one, and I don't know if the alligator clips are, if the probes are in the right direction, like if the positive is to the positive or not. But what I learned from the video is that it doesn't matter. The multimeter can handle it, and it'll just give you a negative number if it's in the wrong direction. So I'm not worried about that. So now this thing is unplugged right now. So now I'm going to take this thing, I'm going to plug it in, and this thing is still 0. And if you look at this thing, nothing. It doesn't have any kind of... So that's not getting any power. So you know that's settled. So now I'm going to unplug this, and now I'm going to connect these maybe closer to where the actual power is to see if this part, like maybe I'll connect it one to this one and one to that one, and I'll see, oh, I bet I know what this does. I bet this thing converts alternating current to direct current. I bet that's what it does. So what I'll do is maybe connect one end to one of these things and then measure the voltage there and see if that thing's getting power. Now I took these probes, and at first I had this on direct current, but then it started jumping around in every place, so I switched to alternating current. And first I put one probe on this part and one part on that thing, and I didn't get anything. If you look at, let me see if I can, I need to find a better way of doing this. It's not touching yet. So that's the fuse, so it should have something. Oh, it does seem to have something there. That's interesting. Okay, well I tried it with direct current setting and it didn't have anything. So now look at this thing there. So that one, I stuck my probes in there with direct current and it was hopping all over the place. I think that's a resistor. And so then I did it with, there we go. So then I did it with alternating current, so you can see it touching there. And look at this, on 123. So that's getting power. This thing is getting power. So that's kind of cool. And that's also teaching me that that is a resistor that can handle 123 volts. So that's probably like a heavy-duty resistor right there. So let me see if I can find something else that I can measure. I'm not sure. I think this thing is ground, because it connects to that thing, and I'm pretty sure that's a ground thing. I'm not totally sure, but I think it's a ground thing. And I don't know what that coil's for, so I'm a little afraid to touch it. Maybe I can like. So these things go to the wire, so that should definitely be getting power. I guess the next thing to test would be whether power is leaving this power converter. I think it's the converter that converts from AC to DC. I guess the test would be, is power leaving this? And it looks like the way to test that is with, I think, these cables. This black one. So this white one is coming from, so I think this white one is a ground. I think the white one's a ground. I think the black one is what I want. So maybe what I want to do is have one wire touching there. So let me switch this first to the biggest DC volt setting. So I've got it on 12 volts. I'm going to stick one in here. So it's touching that. And now I'm going to take the other one. Where is the other one? Oh. And I'm going to touch it to that metal thing, which I think is, sorry, I'm going to touch it to that metal thing there. Okay. So now it's giving me a negative reading on the multimeter, and before I show it to you, I want to make sure I have this thing right. So let me switch my hands. Oh, this is very a messy process. Okay. Okay, so I've got the one there and the other one there, and now I'm going to show you what it shows on the multimeter. It's kind of jumping all, oh, that's millivolts. So 5 millivolts. It's not a lot. That's weird, because when I had it backwards, it was giving me more, I think. Let's try again. So now it's back the other way. No, again, it's just 7 millivolts. Let's see what happens if I switch it to alternating current. I don't think it should be alternating current. I'm pretty sure it's direct current. That's weird. Now it's showing me 13 volts. But I don't have anything hooked up. Oh, look at that. So this is alternating current, and it's 123 volts. So I didn't know that. So that is still alternating current. That's weird. How does that happen? I don't know. I don't know how this is. I don't know how the power's working on this thing. Let's. And if I do alternating current on this one, gives me 0.017 volts. So that would be 170 millivolts. I think. I think you measure it the same way. So that would seem maybe like it's right. 170 millivolts, I don't know. So now I'm looking at this thing for the front panel, and I got this thing attached to my arm now so I can look at it while I'm working. Now if I stick one probe on one of those wires like that one, you see that wire right there? If I stick one of them on there, and if I stick another one like on that wire, it's like the same looking kind of wire there, you can barely see it. If I stick with the other one there, it gives me a reading of like 170 millivolts. And I don't think I can show this because I would need 3 hands. Is there any other way to show this? Maybe if I stick one thing in there. Okay, so I've got that thing perched on a piece of metal, and I'll just stick this on here. So check this out. Look at that. So there's power getting there. There's power getting to that front panel, or at least some of the components. So maybe there's some kind of like blown fuse or something that's keeping it from working. So I just thought about trying to take out this big black piece here, because I saw these 2 screws. I saw that screw there, and I saw that screw there. So I said, oh, if I take those screws out, maybe I can take out this big black piece. So I took the screws out, and the black piece wouldn't come out. And I think it's attached in the front. I think there's probably like another screw or 2 or 3 from this metal part into the black into the front, and I don't have access to that. I would need to take off the front panel, and I don't feel like doing that. But I tried it, and then I realized also that this is a transformer. I recognize this from my Elenco 130-in-1 kit, and that this is also a transformer. And I was wondering what that was before, and now I realize that that's a transformer. So that's cool. But I still don't really know where the problem is with this thing. I mean, it's acting like a fuse is blown, but I don't know where the fuses are. Another thing I learned how to do is, you see this thing and that thing, you can just you can pop them out. So you just pop one out, pop another one out, and they just come out like that. And then I don't remember if I measured the voltage across those things, but yeah, so you can pop them out and you can pop them back in. Let's see. There we go. So that's back in. back in. Yeah, I'm kind of running out of ideas at this point, because it feels like this thing is getting power. If this thing's getting power, then that would mean that if the front panel's not turning on, that it would be some problem in here. So maybe it's this thing, you know, just like in the other video, maybe it's this thing that blew, which I still don't know what this thing is. Okay, so I was able to turn the microwave back on. Let me show you. So it turns back on, and what I did was I first tested the voltage across this thing, and I realized that this lamp is actually getting alternating current. It's getting 123 volts alternating current. And then what I did was I figured out that this cable here, the blue and gray, that's the main power to the inverter. And so what I did was I pulled up this thing a little bit so I could get my probe down there, and I put my probes across there, and I found that that also, as I suspected it was alternating current, and it is, and that's also getting current. That's getting 123 volts. So that means that the inverter is getting power. The inverter is getting power. So now the question is, well, is the, what's that thing called? Magneto? No. Well, is this thing getting power? That's the question now. So let's see. Maybe what I should do, well, first of all, let me unplug. Should I unplug it? Well, I'm going to pull this thing up a little bit. And now I'm going to see if this thing, because that is the power that goes from the inverter up to that thing. So let me see if that thing's getting power. When I connect one thing to there and I connect the other one to there, I don't get any power. I don't get any voltage on this thing. At least not alternating current. So let me try direct current. Let me see if it's getting any direct current. Measuring it for both alternating current and direct current, and for neither of them is this thing getting voltage. So that makes me suspect that this thing is not getting power. I think that's what it means. Magnetron. There we go. There's the name for it. So my guess would then be that the problem is maybe here with the inverter, that the power is successfully going from the input to here, where it's, you know, you have all the switches to turn it off, and then it goes from here to the inverter, and then it goes from the inverter to the magnetron. So I think maybe the problem's here, because the inverter's getting power, but it's not sending it out to the magnetron. So let me see if there's any way for me to pull this thing apart. Oops. So I have managed to cut myself while I was trying to take the inverter out. I cut myself on, I think on this metal. I think I cut myself right there. And it doesn't feel that sharp, but if you brush your hand like that, you can feel there's a sharp edge there. So I think if I just jerked my hand back, that was probably what did it. And so I took some of the wrapping paper that the microwave came in, and then I used a rubber band to put pressure on it, because it's still bleeding pretty good. So I feel like I've just been initiated into the club of people that mess around with these kinds of electronics. So what I learned about how this inverter is attached is that you have these plastic pieces here, and if you look underneath the microwave, you have these 4 plastic pieces. They're all hooked to the right. They're all hooked on a metal piece to the right. And then you have this last metal piece that prevents these ones from moving to the left. So if these try to move to the left, this piece will catch on that metal, and it won't allow them to move from the left. So what I was thinking was, if I just take a screwdriver and I just wedge it in there and I pull that up, I should be able to just move the rest of them to the left. But when I tried that, it didn't work. And so now I'm not really sure what I should do. And the other thing I learned was that these metal things here that are kind of covering it, you can just kind of bend them as you want. They bend back and forth pretty easily. You see that? So I didn't know that at first, but now I know. So that's kind of cool. I'm thinking I may just give up at this point, because I don't really know. Even if I manage to take this thing out, I don't know what's causing the problem in here. So it's kind of I feel like at this point, it's beyond my capabilities to fix it. In the YouTube videos, what the guys would do at this point is they would just replace the inverter. And I don't have another inverter, so I can't replace it. So that's not really an option. If I had another inverter, I might be more tempted to put more time into trying to get this one out of here. But so I think this is like a good step for me as a beginner. I got to the point where I could diagnose where I think the problem is. So that's kind of cool. Yes, I got the inverter out. I'm actually kind of proud of myself. Now the secret was that I didn't notice this thing. This is a ground, I'm assuming. And it was screwed in there, and I didn't notice it. And that was what was preventing me from moving it to the left. So now that that's done, I can just take that out. And I don't really know. Risk of electric shock. Heatsink may be live. Disconnect power supply before servicing. Disconnect power supply. I think this is the power supply. Okay, so to disconnect the power supply, I imagine that I would just kind of maybe unplug that. I don't know. Well, that doesn't look like that gets unplugged. I mean, that's all. These things are already unplugged from the power. And I don't really know how to disconnect the power supply. Maybe pop the circuit, pop the fuse out. Maybe they just mean to unplug it. So, well, there's the thing out. So now I could probably just, let me see if I can. Just oops. Alright, so I now have the, let me unplug my, I now have this thing totally out of the microwave. That's pretty cool. And it occurred to me while I was kind of staring at it that it may not even be that the inverter is the problem. It may be that the inverter is not getting the proper signal from the controller, the thing that you push buttons into. So maybe that's the problem. I'm not even sure how I would test that. And as I predicted, everything looks fine to me, so I have no idea where the problem might be. But it's a cool exercise to take it out. So there you go. That's kind of cool. Alright, well, I got bored of looking at the inverter, so I put everything back in, plugged everything back in again. And I'm just generally bored of playing with the microwave, so I think I'm going to put everything back together, which means just putting on the case. Once I have the case on, that should do it. So I think this is a fun experiment. I'll try to do one thing a week, take apart one thing every week. Don't remember if I recorded a video, but of it being fully assembled again. So if I put everything back together, no one will be the wiser. And now I'm going to put it back in the box so I can return it to Best Buy. But that was a fun little project. Alright, and there it is in the box, ready to go back to Best Buy. So, there we go.